Hi, everyone. This is Introduction to Methods and Statistics. In the first part of this lecture, I'll be talking about psychology as a science, the basics of how we produce and consume research, formulate theories, and how we publish our research. The second part is going to be an introduction to some statistics. We'll go over scales of measurement, and then we'll get into a little bit of math, some summation notation. So let's jump right on in. So to kick this off, we want to emphasize that psychology is a science. Similar to other sciences like biology and chemistry, psychology involves the development of theories, conducting research, collecting data, examining evidence, and eventually publishing this research. Psychology is empirical. So a lot of people, like to think of psychology as a pseudoscience because we are talking about human behavior, which to some people might seem intuitive. But psychology is empirical. It's based on evidence, and it is objective. So in psychology, we both produce research and consume it. So what's the difference between being a producer and a consumer? A producer is responsible for creating knowledge base that we have in psychology. This involves understanding research methods, collecting data, analyzing data, and then communicating the findings. So examples of this would be if I were to administer a survey to collect data, maybe if I ran some experiments on children, conducting brain scans, and then I do the statistical analysis, write up the findings to publish in a scientific peer-reviewed journal. Those are examples of being a producer. In the consumer role, people are reading the research and taking it in and applying it or not. So just understanding what the research is about. So the consumer role is really important because we need to understand how to responsibly take in information. These days, we're constantly bombarded with information, right? How can we tell if it's good or bad? Psychology is all about learning how to be critical, smart consumers of information. So in psychology, these roles often go hand in hand. We consume research in an effort to understand and develop our own psychological inquiry. We come up with our own questions, and then we produce research to learn even more. So speaking of producing research, there's three different types of research: basic, translational, and applied. In basic research, the goal is to acquire general knowledge. For example, if I wanted to learn how narcissistic people interact in social situations or understand the spending behavior among children of divorced parents, these are the types of questions that basic research can understand. So the example I have here is about how autism affects a person's ability to interact with others. So if I just wanted to understand that phenomena, I would conduct basic research. Translational research, here we're thinking about how that knowledge can be applied. So how can you learn what you've used in basic research to solve real world problems? So for example, if you find that the basic research has shown that people with autism have trouble interacting with others because they have trouble often reading body language, you might think about how you can apply that knowledge. So if you're to conduct translational research, you might think about how an intervention or training people with autism on body language, teaching them about that might affect their interactions. So your research would be focused on developing that sort of training or understanding what might that training or what might that intervention entail. And then applied research is really focused on evaluating in real life, applying something in real life and evaluating it to see if it actually works. So let's say you were to implement a specific type of intervention with a specific group of people who have autism, and you want to find out if that therapy or that intervention actually works for this population. So that would be applied research. So you're actually applying it in the real world. The difference between translational and applied is that translation uses basic research to develop and inform the application, and then applied research tests if those applications actually work. Translational research is seen as the bridge between basic research and applied research. Okay, so now I just wanted to illustrate why it's important to be a good consumer of research. In this example, we have a news outlet reported on a new disease called motivational deficiency disorder. It's a condition characterized by overwhelming apathy, and it even reduces the motivation to breathe. So it's a pretty extreme disorder. In reality, it was all a spoof. A reputable pharmacologist came up with this fake disease because he wanted to demonstrate how easy it was for people to report on it and for people to believe it. He demonstrated that it was quite easy, and specifically in this case because it pertains to health, and it seems like it's coming from a reputable source. So this is, I wanted to highlight this because it's important to be a good consumer of research. We often, see false claims. Believing false claims can have real consequences in real people's lives. So understanding how research is actually conducted can help you to become a better consumer. All right, so moving on to our next topic, research always starts with a good theory. So let's talk about how theories inform research and what makes a good theory. So a theory is basically a way to describe how different variables relate to one another. There are different types of theories. You can have the theory about how child development occurs, theories about personality traits, about behavior, about mood, about treatment. A theory is basically a way of trying to explain something. So we always start with a theory. So a theory leads a researcher to pose some questions. So you come up with questions based on your theory, and that's going to lead to a research design. So the research design should be specifically tailored to answer the specific questions that you have. So in the context of the research design, researchers then formulate hypotheses. And so hypotheses are, I guess, a scientifically based understanding of what is going to happen or what is going to be the results of this research design. And then researchers collect and analyze their data, and then that feeds back into the cycle. So if they find that their data support their theory, then that theory can become strengthened, and they can be confident about that theory. They can be confident about how those variables are related to one another. On the other hand, if they find that the data do not support their theory, then they have some options. You can either revise the theory and change it up, or you can improve the way that you design the research. It could be the case that the methods were faulty. Now we'll talk about what makes a good theory. So there are three characteristics of a good theory. First, a theory is supported by data. So intuition, common sense, personal experiences are not support. Again, psychology is a science. You need concrete empirical evidence to support theories. Number two, a good theory is parsimonious. Parsimony is just a fancy way of saying that the theory should be simple. You don't want to complicate the theory with confounds and stipulations and exceptions to the rule. The principle of parsimony is also known as Occam's razor, which states that the best explanation is the one that is the simplest. So as depicted here in this illustration, the most direct path from A to B is more parsimonious. Here's a comic strip also illustrating Occam's razor. I think you should pause to read it because it's kind of funny. All right. So the third, now, if you've noticed, since we've been talking about theories, I've never said the word prove. You cannot prove a theory contrary to popular belief. You might often hear people say things like the study or the research proved that such and such. That is not possible. And this is not something you would see in a reputable scientific publication or from a reputable person. So that's a good way to spot fake news. You can't prove a theory. You can only provide evidence in support of a theory. So researchers will say there's overwhelming evidence of something or the data show something. But yeah, beware of the word prove. You cannot prove a theory. So now I want to help illustrate the theory data cycle. And this example comes from developmental psychology with Harry Harlow. He wanted to demonstrate that infants form attachments with their caregivers because of the security and comfort they experience, and not because their caregiver is merely their source of food or nourishment. So that was in opposition to evolutionary theory, which was prevailing at the time. Anyway, it would have been unethical to use human children to demonstrate this, so Harlow used monkeys instead. He set up these fake wire mothers where one provided food only and then one provided comfort. It was cozy and covered in cloth. So that's just to give you some background on the study. You can read more about it in your book. Now we're going to go through the process of the theory data cycle. So the theory here is that when it comes to infants establishing attachment with the mother, comfort and security are more important than food. That's the big idea that Harlow had, right? So let's evaluate this theory according to our 3 criteria. Can we get data to support this theory? The answer to that is yes. Is the theory parsimonious? Yes, it's pretty simple and straightforward. And is this theory falsifiable? Yes, we can collect data comparing the significance of comfort and security versus food, right? So our question here is, do baby monkeys prefer comfort and security over food? So that question stems directly from the theory. So the research design is that we're going to observe how baby monkeys interact with the fake mothers. One will only provide food and one is only going to provide comfort. And again, that directly answers the question. The way that research is designed is going to directly answer that question that I asked. Next, the hypothesis here would be that baby monkeys will spend more time with the cozy mother. And so, again, that hypothesis stems directly from the research design. So next we need to determine how to collect the data. Now we'll get more into this when we talk about measurement later on in the semester, but I'll just say now that it's really important to think about what type of data you will collect. Or if you're evaluating a research study, it's important to ask what kind of data was collected. How did they operationalize the variables? In this case, we want to know, how did the researchers decide how to determine whether comfort was more important than food? What kind of data did they collect to make that determination? In this case, we're using time to determine. So the data collected was the observation of the amount of time that baby monkeys spent with each mother. There may be other ways to measure this variables as well. So in this study, if the monkeys spend more time with the comfy cozy mom, that would support our theory that comfort and security is more important. If they spend more time with the food mom, that would fail to support our theory. Notice we did not say prove. So a quick recap of what we've covered so far. We talked about 3 types of research: basic, applied, and translational. We talked about the what makes a good theory, so supported by data, parsimonious, and falsifiable. And then we also talked about the theory data cycle and went through an example of that. So now we've conducted this research, we have to make it public, right? So a researcher has to consider what type of journal they're going to publish in. You want to publish in a reputable journal, a journal that's known for being trustworthy. A journal has an editor who oversees the publication and is responsible for what's in it. And then there are also peer reviewers. Peer reviewers are experts on the subject of the journal, and they review the papers and evaluate everything about it, from the methods, from the data analysis, from the interpretation of the data, everything about that paper. An important thing to note here is that the peer reviewers remain anonymous. So the researcher does not know who the peer reviewers are, and very importantly, the peer reviewers do not know who the researcher is who wrote this paper. That is the aspect of the peer review process that allows for honesty and integrity. So you can be sure that the reviewers aren't just passing along papers because their friend or their colleague wrote it. They're being fair and just because they don't even know who wrote this paper. So the peer review process is rigorous, and I'll walk through the steps of how that goes. So a researcher will submit their paper to the journal. It's going to go straight to the editor. The editor is reviewing the paper just to see if it's relevant for this journal. If not, they reject it. The paper will not get published. If it is, the editor is going to send the paper on to the peer reviewers. Oftentimes there are 2 reviewers. Some journals have, different numbers depending on the journal. So the reviewers will comment on the pros and cons of the paper. They'll make extensive recommendations of the paper. Ultimately, they will recommend to the editor whether or not this paper should be published. The editor is then going to make the final decision. So the editor can decide to reject the paper, and then the paper is not published, or the editor can submit a decision called revise and resubmit. And this is a very common decision that a researcher will get back. This just means that the reviewers believe that there's a lot of merit in the paper, but they want the researcher to reconsider some things or change some things around. And so in that case, the researcher will revise the paper according to the recommendations and then send it back to the editor. Another decision that could be made is that they can accept with or without revision. So if they accept with revision, that just means that the paper is mostly there, but there's just a couple of things that need to be changed. If it's accepted without revision, that's probably rare, at least in my experience, but that means that the paper is good to go and ready to be published. All right, so this is a good time to pause if you need to. In the lecture, we are going to start the next section. For the next section, you might want some scratch paper, something to write with, as well as a calculator. Also, I reference a couple of videos that I have posted on iCollege called Scales of Measurement, so you can take some time to access those as well. If you are taking a break, go ahead and hit pause. Otherwise, let's continue. We'll start by talking about scales of measurement, which just refers to how we classify our data. So people usually think of data as numbers, but what do those numbers mean? What are the properties of those quantitative values? So scales of measurement can help us assign values to these observations. Observation just means the data that we have. So there's 4 different types of scales of measurement. There's nominal, ordinal, interval, and ratio. I'll talk about each one of these and give some examples. So nominal data is categorical or qualitative. It's name only. It's basically just a category. So examples of this might be things like favorite color, marital status, ethnicity, political party. These are examples of nominal data because there's no real quantitative or numerical value to these data. They're just naming things or placing people in a certain category. So ordinal data is data that can be ranked or ordered, but there's no true distance between the numbers. So for example, if I asked you to rank your top 3 favorite TV shows in order, so the distance between 1 and 2 might not be the same as the distance between 2 and 3. So ordinal data do have a meaningful order. 1 is better than 2, 2 is better than 3, but the difference between the data points is not meaningful. Now, interval data, there is equal distance between points on a scale. So an example of this, we can think about temperature. So if I have 25 degrees and 30 degrees, the difference between that is 5 degrees. It's going to be the same if I had 65 degrees versus 70 degrees. The difference is still 5 degrees. So there's equal distance between points all throughout the scale. However, with interval data, there's no true zero. And what we mean by that is that there's no such thing as an absence of that variable. So in our temperature example, if there's no such thing as having an absence of temperature, if I had 0 degrees, that would still, the temperature exists at 0 degrees. Contrast that with ratio data, where it's the same as interval, but there is a true zero. So an example of this, we can think of money, like dollars. The difference between $25 and $30 is $5, is the same as the difference between $65 and $70, right? So we still have a meaningful distance between points, but you can have an absence. So if there is a true zero. If you had $0, that would mean that you had no money. All right, so that was just a quick overview of the scales of measurement. You should watch the 2 short videos that are posted on iCollege under the Week 1 tab. There's also a short practice of this in the PDF slides, as well as a practice set on scales of measurement posted on iCollege. So be sure to check those out. All right, let's go ahead and move on. Next, we're going to learn about summation. You'll need this skill to compute and even read some of the formulas that we are going to use in statistics later on in the course. Before we get into summation, let's go ahead and review order of operations, which you might be familiar with from high school or previous math classes. And you might remember the acronym PEMDAS, or some people know it as Please Excuse My Dear Aunt Sally. Just a good way to help you remember the order of operations. So we start with parentheses, then we move on to exponents and roots, then we do multiplication and division, and then addition and subtraction. So I want you to go ahead and do this quick practice problem here. You might want to go ahead and press pause before I reveal the answer. All right, so I'm going to walk through how to solve this. Again, we're following the order of operations. So we're going to start with what's in the parentheses, 4 times 3, and that's going to give us 12. Our next step is to go to the exponents and roots. I have a square root of 16, which is 4, and then I have the exponent to the right of the parentheses. So when I'm squaring something or taking something to the second power, I'm going to multiply that number by itself. So 12 times 12 is 144. All right, so we're still breaking down this equation. Next, we're going to do division. So we have 4 divided by 2. That's going to give us 2. And then finally, we have addition, and that's going to give us our final answer, which is 146. All right, so now let's start with summation. So this symbol that you see here that looks kind of like a little funky E, it's the Greek letter called sigma, and it means total or sum. So whenever you see this symbol, your goal is to find the total or sum of whatever appears to the right of the sigma. So variables are going to be symbolized using capital letters. Most frequently, we use X and Y. Variables have multiple different values. Constants are symbolized using lowercase letters, usually C. Constants don't change, it's just one value. That's why it's called a constant. Each score on a variable is going to be noted in subscripts. So X subscript 1 or X sub 1 or X1 represents the data point for X, the first data point for X, and then X sub 2 is the next data point, and so on and so on. When you see a variable letter, that letter is going to represent all of the scores or data points for that variable. So for example, here's some data in this little chart to the bottom left of the screen. So we have all of the data points for variable X. X sub 1 equals 3, X sub 2 equals 2, X sub 3 equals 4. So these are different data points for that one variable. So whenever I see X, that's going to include all of the data in that chart. So these rules are going to make more sense as we apply them and try to solve these summation problems. I have 5 examples to show you, so we'll walk through those. All right, so in this table, we have some data. We have variable X, variable Y, and then we also have a constant. And then I've also included the order of operations table here for you to reference as we go through these examples. There are going to be 5 examples. All right, so here is our expression. We have sigma and then X. So that's find the summation symbol and then variable X. So let's just talk about how to interpret that. X represents all the values of X. And then, of course, the sigma symbol represents sum or total. So I can interpret this phrase as find the sum of each X score. So that's exactly what I'm going to do. I'm going to take each X score and find the sum. So I have 3 plus 2 plus 4. And so the answer to this expression would be 9. Moving on to the next one, this example includes X and Y. And so whenever we see the two variables side by side like this, that means that we're going to multiply them together. So I would interpret this as multiply each corresponding X and Y score and then find the sum of the resulting values. And so I'm going to multiply X sub 1 times Y sub 1, X sub 2 times Y sub 2, and then X sub 3 times Y sub 3, and then I'm going to add all of that together. And so that's what this is going to look like. Find the answers there, and then finally the answer is 51. So I'm kind of just going through these. If you would like, you can go ahead and pause after every example that I showed so that you can try to attempt to solve it on your own before seeing the answer. Okay, the next one is finding the sum of x squared. So I would interpret this as square each score of x and then find the sum of all of the resulting values. So I'm going to take each one of those values and square them and then add all of them together. And then the final answer for that would be 29. All right, another example. So here we have x plus c. And so now we're involving the constant. So I would interpret this as add the constant to each score of x and find the sum of the resulting values. So I'm going to have I have three different values for x, but remember that the constant always stays the same. So I'm going to be adding 2 to each value of x and then finding the sum of the resulting values. Okay, so that brings us to workshop number 1. This is our first workshop of the semester. You can do this on a sheet of paper and upload it to the corresponding file under the assignments tab on iCollege, or you can download the workshop 1 file that's also on iCollege. If you have any questions about how to go about the workshops or what to do, feel free to email me and I can clarify. I've also explained it in the course intro video as well as in the syllabus. But if you need any clarification, don't hesitate to ask. All right, you made it through the first lecture. Hope it wasn't too painful. If you have any questions or feedback or suggestions, feel free to email me at cwilson60@gsu.edu, or you can even set up office hours and we can chat. All right, take care.